Hello ladies and gentlemen, and welcome to this tutorial on building and designing metal detectors. As you can see here in this tutorial, which is going to be multiple videos, actually this is going to be a very long tutorial. So the reason for that is this. Now, while I was first trying to learn about metal detectors, how they work, how to build their circuits, like almost 99% of the videos on YouTube either doesn't work or they are just like toys, right? But if you want to build a metal detector, you want a metal detector that is capable of detecting coins and many other relics on various depths under the soil, right? Because let's imagine here we have, this is the soil surface, here's your metal detector, right? And maybe there's a coin here, maybe there's some relic here, and the distance could be maybe like 30 centimeters. This one could be at a depth of 1 meter, but most videos on YouTube doesn't teach you how you can build such a thing. There's many caveats to metal detectors. There's many design considerations when we are talking about metal detectors. So to understand metal detectors and learn how we can build circuits that can detect small things at the surface level or even at a depth, or maybe if we want to build a metal detector that's very powerful, that can detect stuff at very large depths, maybe 1 meter or even more, all right? And trust me, after finishing this tutorial, you will learn how you can do that. Now, the other thing I want to say is that this tutorial is going to be unscripted, so I will not prepare anything. I'm not going to edit the videos. You will see me as I go. I will teach you anything that comes up to my head. So you will learn everything about metal detectors. So let's get started. And first of all, learn the basic idea of a metal detector, because many videos on YouTube, or almost all of them, they don't teach you the exact science of a metal detector. So a metal detector is an electrical circuit, right? So here we have some stuff like capacitors, resistors, and so on. And part of the circuit is an inductor, right? So this inductor, which is basically a coil, so coil, in physics terms, we call it inductor, right? This inductor have a property which is called induction, and we give it the letter L, all right? So induction basically means that this coil, right, is emitting electromagnetic waves, right? So if we take another look, let's imagine this is the coil, right? It's connected to the circuit, and the other component of the metal detector, it's emitting waves. So let's say these are the waves. These are electromagnetic waves going around this coil, something like that, all right? And from this, we can see that the bulk of the magnetic waves are in the center of the coil, right? And as we go away from the center, these electromagnetic waves becomes weaker and weaker. And when there's a piece of metal in the vicinity, so let's say a metal is here, since this induction property is dependent on the electromagnetic waves, right? This metal, once it's experienced these, let's say, electromagnetic waves, right, then it will be magnetized itself. So this piece of metal will become a temporary a magnetic for a short period of time, right? So as a result, then this magnet will affect the induction of this metal detector right here, or this coil. So these waves, then the value of the induction will change, right? And since it can change, that means there's a metal. So it goes both ways. Now, because it's changed, now the circuit, so part of the circuit will be responsible in detecting this change. All right. So any metal detector in existence, no matter what type it is, it contains two basic units. One unit is responsible for operating the coil, right? And another unit is responsible for detecting the change. So this is the first thing you need to learn about metal detectors, is that first we need a circuit for operating, right, the coil. And we are going to talk about this in depth and how we can design these circuits, how we can increase the range, decrease it, because there's not always we want to increase the range because, well, there's a lot to talk about this subject. Actually, it's worth its own video, so let's keep it for another video for now. And part 2 is another circuit for detecting the change in induction, right? Once we detect a change, that means we have a metal in the vicinity of this metal detector. All right. Now, let me think a little bit here and use my electrical engineering mindset here, or mind, to try to guess some things, right? Think about things. Since we are depending on the electromagnetic waves that are radiating from this coil, that means stronger waves will have, first of all, they will spread farther away, right? Second of all, this means that stronger waves will make this piece of metal a stronger magnet, right? That means higher sensitivity, because stronger magnet will have higher effect on the coil itself, right? And as a result, it will be higher sensitivity. So if we think about it for a little bit, this means that what we need to do to make a metal detector more powerful is to make stronger magnetic waves, right? That means many things. We will talk about them in later videos, but that means we can increase the induction. So this will increase the sensitivity. Also, we can increase the voltage that the metal detector is operating on, right? So this makes higher frequency, or sorry, makes stronger magnetic waves, right? Means higher depth. And the size of the coil itself. So smaller coil versus larger coil. Now all of these I'm going to talk about them on separate videos on a more in depth, because they are worth that. But as I am telling you, these videos are unscripted. I don't feel like making scripts and planning everything. I am not a planner at all. I just, whatever comes to my head, I talk about it. Anyway, so smaller coil means that these waves will not spread away far away. So they will be very, very concentrated around the coil. That means smaller coils will have very high sensitivity, but this will be for short distances, maybe from let's say 1 to 10 centimeters, but they will be pretty accurate, pretty sensitive. Can be more, can be up to maybe 30 centimeters, all right, depending on coil size. Larger coils, if we pass the exact same current through the coil that we pass through the smaller one and apply the same voltage, this means that the electromagnetic waves will spread farther because we have a larger coil. So that means since these are spreading farther, these will go deeper into the ground, right? But the thing is, these are weaker now because they are spread away. So these will not be able to detect coin, for example, but they will be able to detect relics, right? And then again, we'll talk about these in later videos, but for now, I'm trying to give you a general overview of a metal detector, how it works, and such stuff. Now let me just see very quickly here how much we are into this video. 10 minutes. Oh my god. All right, so that's it for this video, guys. Thank you very much for watching. I will see you in the next video where we'll be talking about the different types of metal detectors.